Let's start since it's 4 p.m. and thank you so much everyone for joining us. We are doing a short event to celebrate that we're launching our Alpha 2 version of New Golem, which is a brand new platform that we have been building for at least a year. And we're gonna have a really exciting layer 2 panel with some of the best solutions in the market. With Optimism, we're going to have Kelvin from Optimism, Kasima from OMG Network. We have Alex from zkSync and Jay from Loopring, who will join us as well. And then from our side, no, Matic is not here, Calpad, but next time we'll invite them. We have very little room for everyone, and we wanted to give everyone proper voices. I'm just answering questions on the fly, by the way. And then from the Golem side, we will have two short presentations. One is on our very shiny and new architecture, which Mikolaj will be giving here, and then we will have Kuba with a walkthrough through the current iteration, the Alpha 2 one, which is very exciting because you're already able to build on top of Golem, and apparently it works really well. We have been having a couple of Gitcoin bounties. People have been already building. We already have the first transcoder built on top of Golem, so we are super excited and happy to be here. So without further ado, I'll pass it on to you, Mikolaj.
Thank you, MP. And hi, everyone. Thank you very much for joining this. I'll try to make myself really brief, and MP, stop me when I go into too much of a monologue here, because I like talking about this architecture very much. It's so exciting for me. This is the second reveal of the new Golem, and it's about time to actually start showing on like how it works on the inside. So my story with Golem began 2 years ago when I joined the Golem factory team at the times where Golem Brass was operational and Golem Clay was being built. But my task at that time was actually to facilitate the extraction of all the experiences and all the findings of the prototyping that Golem went through over the years, and gather the guys' experiences, gather the guys' potential and their thoughts and concepts to build an open, new, proper architecture of the Golem from the start. We've been working on this in the background, and the new Golem, the alpha that you're seeing now, is the implementation of it, the first incarnation of it. The point of this architecture was for this to be open. It had to be generic enough so that it could carry and support all sorts of computing resources which you can imagine, which you want to share and trade for tokens. We wanted our architecture to be as modular as possible, and we wanted this to be built of interchangeable modules, the ones which you can develop, you can enhance independently, and you can swap. We felt we needed a structured approach to this, so we actually had to develop a method of working on this, but definitely we wanted to relate to industry standards where it was applicable, and again that was to support the openness of the architecture. So from the 1.5 years of history of this, I feel we are getting there. And my objective for today is to just give you a quick walkthrough of the main concepts of this architecture. So in our works, when we were actually dissecting the concepts or the idea of Golem's vision, we realized that we had to decompose all the aspects into chunks and manage them independently. So this is why we came with the concept of the building block, and we felt we had to start from the bottom, where we realized that we actually had to find a way to describe all the computing resources that we would want to share and trade on the Golem market. And subsequently, we would then define the ways of interaction of the applications or the Golem nodes with the Golem marketplace and the Golem network as such. So we actually went into designing the protocols of interaction, and they became our building blocks. We wanted to build an abstraction of what we call execution environments. So the ways of actually hosting the resources that the provider would like to share and trade. So think of execution environments or exe units as a way to host a Docker image, as a way to host a VM, host and run a WASM module, host to run, I don't know, a Java module, a .NET class, whatever. So again, these are modules which we would want to add into the Golem ecosystem. But because one of our main users as such are the developers of Golem compliant applications, we also had to put focus on the SDK. So our goal is also to provide a usable set of SDKs and libraries to enable integrators and developers to actually write the applications running in Golem. But as I said, we started with the generic specification language for the computation for computing resources which are there on the market, and that was designed in a way that is open, i.e., almost any software implementer can actually define and specify resources that their application has to share. Golem Factory provides plumbing for the network, and it provides the mechanisms for agents, for providers, and for solution developers to publish themselves on the market or publish solutions on the market, and so that the users and consumers can actually use them. So the purpose of the architecture is to abstract from the specific computing resources. We want to abstract from whether that's a VM, a WAS module, whatever. We want to provide a tool that others can take and use to share the resources that they would want to share. And that's the capability that the spec language gives us. But then on those demands and offers, our fundamental APIs operate. So they touch upon aspects of market interaction and negotiation. So actually, we allow the nodes to match or find each other, and we allow requesters and providers to communicate and negotiate. We control the consumption of the resource, whether that's an execution of a Docker module or whether that's a sharing of a VM. We regulate or specify the interaction on the payment side, and we have a protocol to manage the identities and rights and access. So these are all low-level Golem APIs, which have been implemented in what we call Yagna. And so it's a set of software components which you have already seen in the first reveal. So now we've just published the second reveal of it. Yagna is the reference implementation of those architectures. It's not the only implementation possible. It's the one which Golem Golem Factory publishes. It consists of a daemon module, and think of it as the gateway which the applications can use to connect to the Golem network. It contains exe units, so different or various execution environments. Right now we have two. We have the WASM exe unit and we have a VM exe unit, which is also capable of running Docker images. We have the provider agent, which is like piece of logic, which sort of publishes the resources on the network and controls the commercials and terms of sharing and of consumption. On the requester side, we have agent applications, which are the ways for the consumer to actually connect to the Golem network, connect to the provider and use the resources shared, then control the payments for those resources. So as I said, right now, the Golem Factory provides implementations of the daemon itself, the exe units, and the provider agent. We are publishing libraries and SDKs for the integrators to write their own requester agent apps, which would be like the first the easiest step into the Golem ecosystem. And that's actually covered by the SDK that we are publishing. Instead of dealing with those low-level APIs, you actually have libraries which are facades, which hide the nuances of those low-level APIs. The libraries are dedicated for specific language platforms. So right now we have two: the YAP API for the one for Python, which is pretty much stable. We have, with Alpha 2, we are publishing the first version of JS or JavaScript API, and these APIs are also covered in the tutorials which we are publishing, and we keep getting them, or we're keeping the tutorials up to date and enhanced with samples and use cases. The purpose of this is to demonstrate or illustrate to the integrators the ways of leveraging the Golem ecosystem potential. So with each of the reveals and each of subsequent iterations, we will have more to reveal, to show. We have a couple of new exe units in the pipeline. One of the interesting ones is the one which includes the SGX trusted enclave, so gives you an ability to run a trusted execution environment. We also have in the pipeline enhancements to the payment mechanisms which Golem ecosystem will support. This is actually an interesting area, and this is something that Kuba will touch upon when describing the approach to layer 2. So these are the fundamental concepts of the Golem's architecture. We have started revealing them as well as part of our blog post sequence, and we will reveal them together with the Yagna source code base and with the standards and specifications which will come along with next reveals. That's really it. Off to you, Kuba.
Thanks, Mikolaj. Thanks for this amazing, short, quick presentation. And I cannot stress this enough. This is like 1 year of work of our developer that comes like to this point. Like we released like the first version on August, but it was like very simple, just to release it out there. Now this release, this is a breakthrough because like developers can finally join and start writing apps on top of Golem. And like so we already know, thanks to Mikolaj's presentation, that in the Golem network there are like requesters, so developers that need computing power for their application, and providers, so people that have some you know, Linux hardware and want to get some nice yield and go Golem farming or something like this. Anyways, I want to make it short, and I actually want to show you something. I want some kind of a live demo, although I know that this is risky, and I haven't warned the team that I want to do it. So
no worries, I can disconnect you if something goes wrong.
Oh, cool. That should work. Just tell me if you can see my screen then.
Yeah, it's there.
I just probably have to clean up the Zoom from here, and that should work. I have 2 monitors, so like I'll be looking in a weird direction. But anyway, on the left, there is like our brand new documentation website called Handbook Golem Network. And you can find here everything about, you know, how to become a provider or how to start writing your application as a requester. And actually, I want to start with becoming a provider because I imagine some of you are not technical and won't be writing application on top of Golem. So like becoming a provider is quite simple, like assuming you have this Linux hardware and you can like, you have like the basic command line knowledge. It's just like copy pasting this installer that we prepared, and that should do it. That should kind of install the whole daemon for you, and after it installs, it will ask you like for 2 configuration options. mentioned. So like how do you want to call your node? So this will be visible in the network. And the second one, like which subnet of Golem network you want to join. We have this concept of subnets. So like, for example, now we have separate subnets for developers who are trying to write apps, and a separate network for providers, which the subnet that is called community. So now it's done. Let me just run it. This will be like a lot of logs, and voila. That's it. You know, the provider is working here. So assuming the requests will come, I will be earning NGNTs on Rinkeby based on the tasks that my provider, my Linux hardware executed. And yeah, that's pretty much it. That's enough. That's what you have to do to become a provider. And so now the part of the requester. And actually we have like basically two tutorials there. One is like a super quick primer. So like a really fast way to onboard into becoming like a creator of an app on Golem. It will just allow you to kind of run the simplest possible or almost simplest possible app on top of Golem. So this is actually like kind of an internal joke, because we've started with Blender. This is actually in a very simple way rendering and some like 6 frames using Blender in Python. And I actually copy pasted the tutorial into this file. So these are just the comments from the tutorial, and I will run it. If we're lucky, we can get some proposals, or we already have an agreement, and agreement is confirmed, and we're sending tasks to Golem network. So in a bit we should see some cyan colored messages that we received some tasks. Oh yes, task computed. So yeah, that's really simple with this documentation and with the current architecture. If you want to create your own application, that gets only a bit more complicated. You go into our like create your own application on Golem, and basically like you're using our high-level Python API or high-level JavaScript API that abstracts everything for you and just allows you to send the computation into the Golem node. Actually, the only complexity is handling the image that you're using. So like your code is executing inside the exa unit, so you have to prepare the image with all the dependencies that your code needs. And yeah, we actually, we know that a lot of developers know Docker. So like we actually allow you to create your image as a Docker image. And then you use a tool that we've built that's like called GVM Kit that transforms the image from the Docker format to our Golem format. So under the hood, we're actually like using KVM and QEMU to run this. So we're not using Docker itself. And after you pushed your image, it's available to all the providers, and your code, like as a requester, will be able to execute. And yeah, that's simple. And this tutorial like will kind of get you through the whole process of creating your own app on top of Golem. And this is actually happening already. So MP mentioned Gitcoin bounties, and this is like we are 3 days or so after the release, and we already have like a video transcoder here that was written by one of the developers. Let me try if that works. So I'm not sure. I haven't tested this like just before the presentation, but hey, something is happening. We can see that, you know, this applications is allowing me to upload my file and transcoding it into multiple video formats using multiple Golem nodes. And yeah, I'm very excited. And probably the last thing that I want to mention that kind of leads us to the layer 2 conversation is that layer 2 is a must-have for Golem. And for now, Alpha 2 is supporting only like layer 1 and ERC20 and GNT token transfers. But we're working on the layer 2 solution for transfers, and this will be available on the December 1st. So yeah, I guess it's time to for the panel, right?
Wow,
Yeah.
just give out a date. That's bold, huh? That's really bold.
I'm bold. I'm bold.
Now you need to work, actually. How dare you?
All right, well, I think I'll be diving into the panel. So my name's Mattias, and I'm super excited to be moderating this panel of the great minds behind Layer 2 and Layer 2 adoption. So thank you all for joining. To start off with, I'm just going to go around and ask each of the panelists to introduce themselves and their project, and then I'll give them a question. And depending a bit on the time and how discussion goes, we'll try and have a second round of questions after that as well. Before we dive in, I also want to point out that I want to encourage panelists to bounce off each other's ideas. So if you want to go more into a particular topic, that's completely okay. And I think particularly after the first round, it will be fun to get a bit more discussion going. So to start off, I'm going to ask Jay from Loopring Protocol to give just an intro and a brief introduction of Loopring.
Sure. Hey, thanks, Matthias. Hey, guys. My name is Jay, co-founder and CEO at Loopring Protocol. I think Loopring is the first layer 2 decentralized exchange. We have launched our mainnet on layer 2 in February this year. We are using a technology called zkSync to scale the Ethereum TPS from 15 TPS up to 3,000 transactions per second. And we are also building up 2 products. One is Loopring IO decentralized exchange. Another one is Loopring Pay. It's also I think it's the first payment solution on layer 2. If it's not correct, please correct. If it's not right, please correct me. Thanks.
All right, thank you. So Loopring Protocol allows for a decentralized exchange of cryptocurrency tokens with the popularity and demand increasing for such decentralized exchanges. Do you foresee a future where such options will outcompete centralized exchange options? And how can we as a community try and push this mindset? Jay.
Oh yeah, I believe so. Actually, it's happening now. We have seen some DEX overtaking central exchange in terms of trading volume. For example, Uniswap, they has more trading volume than Coinbase last month. I think the most important reason is because the AMM, and the AMM can do things that central exchange cannot. So we think the trend is unstoppable. So Loopring will also support the AMM on layer 2 in the end of this year, and will outcompete with central exchange on all fronts. So eventually everyone can access decentralized exchange to trade or exchange crypto on their smartphones. And I believe the community can also do a few things to help push people to onboard layer 2. For example, by providing more educational material to community to help them to better understand layer 2 technologies, pros and cons, and also like do those instruction videos and guidelines to help them to use those kind of say wallet like MetaMask, those things. Yeah.
Awesome, thank you. All right, so moving on to Kasima from OMG Network. I'd just like to ask you to give a brief overview of yourself and also the project OMG Network.
Sure thing. Hi, I'm Kasima. I'm the CTO of OMG Network. We are a value transfer layer 2 scaling solution that's built on Plasma. I think sort of maybe people need a bit of a refresher on Plasma, maybe not you, Kelvin, but everyone else might need a bit of a refresher on Plasma and how it's different from the other layer 2s here. So I'm the only project here that's not a rollup. So the key difference between Plasma and the other rollups here is that we don't push all our transaction data on chain. The rollups do. And so that ends up, we end up pushing a very small amount of information to L1, which means that we can do very high throughput and at very low cost. There's obviously some trade-off to that. So we end up having a bit more complexity in our protocol, which limits a little bit of our flexibility. So we can't necessarily offer generalized smart contracts, but we do. Our system is built on the work that Plasma Group did last year around Plasma predicates, and so right now we offer value transfer, where we hope to offer other sort of Plasma security applications soon. So that's sort of what we're focused on. I think high scale, low cost, and we're kind of squarely aimed at sort of the CeFi exchange ecosystem right now, and of course, OMG Go, as some of you probably know, that it was originally founded to sort of pull some traditional finance applications onto the network, and so we're hoping that our set of trade-offs can enable some of these applications to come over to crypto that wouldn't be possible on layer 1.
All right, awesome. Thank you for that. So just a question to go into that topic a bit further. So Tether is actually a huge driver for adoption of cryptocurrency. And 2 months ago, they announced that they're integrating OMG Network to help reduce Ethereum congestion, gas fees, and improve transaction speeds. How much of a positive impact do you think onboarding such a large project using Ethereum to layer 2 has had on improving gas and congestion of the overall network?
Well, we were obviously incredibly excited to be able to integrate Tether. It was at the time, the token itself was the #1 use of gas on Ethereum by a good amount. That of course was before DeFi summer, and now it's #2, but that's still a massive use case for Ethereum. But there is some detail into how that integration worked. So the detail around that is it was Bitfinex that integrated the ability to deposit and withdrawal out of OMG Network, and they support USDT deposits and withdrawals. So they're a big use case for us, but they're still sort of a single destination on the network, other than the smaller integrations that we have so far. So while we're incredibly excited to get them on board, we're still working really hard to get basically more in the ecosystem on board. So I can't say that we are pulling a lot of L1 transactions off yet, but as we talk to more exchanges and more wallets and more custodians and get them on board, we're really hoping to pull a lot of that sort of like basic sort of value transfer off of layer 1 onto layer 2, and hopefully like we hope that by pulling some of the stuff off, that we create room for some of the more experimental DeFi projects and even room for some of the layer 2s to operate more efficiently. So I think it's sort of a slow, hard slog for us to sort of build the network up and build the integrations, but we're hoping that's sort of going to grow over time.
Yeah, for sure. It's a bit of a process, right? But that's why we kind of want to have these events as well and try and spread awareness of layer 2 and just helping Ethereum grow a bit more.
Yeah, absolutely.
Yeah. And now we're going to go onto Alex from MatterLabs. So I was just hoping to ask Alex to give a brief introduction of himself and overview of zkSync and stages of the development that you've been going through and where it is now.
Sure. Hi, everyone. My name is Alex. I'm co-founder of MatterLabs, and we've been working on zkSync as our main product for last year. And zkSync is a zk rollup for scaling generic computation on Ethereum. Right now, it's live in production for value transfers, where ERC20 tokens can be transferred. But we're working on making layer 2 generic with zkSync, a new programming language we created for programming smart contracts on zk rollups. We want to make it possible to have anything you can do on Ethereum do in a zk rollup. And why it's important is that zk rollup is the scaling solution which gives you guarantees of security, which are essentially the same as layer 1. So cryptographic assumptions aside, it's exactly the same protocol security as layer 1. So you can put money in, go away for a year, no one does no work, and you come back and you can be sure that you will be able to get your tokens back. So yeah, that's roughly the description of zkSync.
Cool, great, thank you. So just onto the question that I wanted to ask. So are there any new possibilities that open up with the adoption of zkSync, which don't exist in the same way on layer 1? And do you suspect that there might be some possibilities that we might not yet be aware of?
Absolutely. So, well, one generic possibility which is present in zk rollup, which you cannot do on layer 1, is that you can onboard millions of users. You can actually aim for mass adoption. And if we don't get mass adoption with crypto, then we failed with the big crypto vision, which we're all working towards. And it's simply not possible on layer 1s, which are sufficiently decentralized. So you can have that, plus you can have much lower latency, because since the validators in the zkSync network are completely untrusted, you can have less of those validators, have them process larger volumes of transactions, and give you confirmations within a second, essentially. So you have very nice UX where every transaction is instantly confirmed, still secure, with low finality, is settled on Ethereum. And finally, you can have things such as privacy, which are going to be much cheaper on the zk rollup compared to any other scaling solution, because it's native to the technology which drives zk rollups. So you will essentially be able to have private transactions at roughly the same cost as normal ones. And I'm very excited about this, because privacy is also one of the essential components of bringing crypto mainstream.
Yeah, for sure. Super important topic. I agree on that one. So thank you for that. And now we're going to move on to Kelvin from Optimism. So I'd just like to ask Kelvin to give a brief introduction of yourself and also go a bit into Optimism and what you're working on and your progress.
Hello. Hi, yeah, I'm Kelvin. Work on Optimism over at Optimism. It's an optimistic roll-up system. Yes, very original name. And the sort of core philosophy there is that we try to make that system as close to Ethereum as possible. So unlike sort of some of the other projects and the zk rollup projects, we don't use any fancy crypto, and instead we essentially get the ability to run any Ethereum smart contract. So you can just write your smart contracts in Solidity and use the same set of smart contracts that you're using already, and then deploy it to this layer 2 system and just have it work. So that's sort of the cell of Optimism.
Yeah, awesome. Thank you. So just to follow on with the question. So Optimism has had interest in demos created with large projects such as Synthetics, Uniswap, and I think Chainlink as well. What are some of the key reasons that you've come across that such projects are interested in layer 2 scaling?
Layer 2 scaling in general, I think the big thing right now is that fees are so ridiculous that a lot of these projects, their users are basically not able to actually capture the value that they expect to capture. And so as a result, essentially because the fee of actually withdrawing that value is higher than the value itself, which is sort of disappointing. So and then the draw of those projects really to Optimism specifically has been the fact that they can just take their existing smart contract architecture, tweak it very, very, very slightly, and deploy it to the network. So.
Yeah, right. Sounds a bit similar to some of the reasons why Golem also decided quite early on that they would eventually need to adopt layer 2. So thank you for that. And just following on, so now we're going to go to Kuba, and we've already had a bit of an introduction about Golem. So let's dive into a bit more of the topic of layer 2 and Golem, since Golem is actually one of the projects that's working on adopting zkSync. So Kuba, what was the motivation behind implementing layer 2 payments into new Golem, and some of the challenges that you've encountered already or have been identified as hurdles to overcome in the future?
Yeah. Golem is this kind of application, this kind of use case on Ethereum that Vitaliks like to talk about. It's like non-financial and could be probably excluded by high fees. And in February, where we are like kind of deciding what to do next, we are seeing like already fees that were like too expensive for Golem, and we knew they will get more expensive. We had no idea this will get that crazy. But anyway, the classic solution when you don't have any types of scaling is to do batch payments and do like payments every 24 hours or every week or something like this. And this has been done in a previous versions of Golem, but it introduces like a monstrous complexity for the developer, and kind of includes all the possible issues that come up with that, like reputation and resolution and others. And we're definitely optimizing for developers. We want to make it for them as simple as possible. So the simplistic solution for this kind of problems is to have like very, very small requests and very, very small payments. So like providers have little to lose by executing computation they will not get paid for, and requesters, they don't have a lot of lose because they just pay a tiny amount, and if the provider doesn't do a thing that they're expecting, they can just graylist them or stop cooperating with them. But this requires like micropayments, and I mean like micropayments, I mean cents. And for Golem, it doesn't have to be super fast, but it has to have the capacity, and because of our values and who we are, it has to be secure and decentralized. Also, it doesn't have to be like smart contracts, because all the logic for like marketplace and demands and offers is inside Golem itself. So we're just doing payments using blockchain. And to be honest, we chose zkSync in February because it was already there. It looked promising. There was a wallet to try it out. There was like a functioning explorer. That was cool. It was like nearing mainnet launch. But our architecture allows for like multiple payment drivers at the same time. So I can imagine, I foresee like all of the projects here having like a payment driver payment driver for Golem, and Golem being able to support most of the layer 2 solutions out there.
Yeah, it's super exciting. I think there's definitely space for lots of different scaling solutions on top of Ethereum. So thank you. So now we're going to go kind of round 2 into some of the questions, and I want to reiterate that it's going to be a bit more casual. So if you want to jump in, or if something pops into your mind, or maybe even if you come up with your own question on the way, that's totally fine. But I'll still direct it at people to start and then keep it a bit more casual. So going back to Jay from Loopring Protocol, were there any challenges that you didn't expect while onboarding projects? And if you could go over some of the tips that you would give to projects that are looking to adopt layer 2 protocols.
Yeah, sure. Actually, it's quite funny because our strategy is not trying to be friendly to onboarding other project to our layer 2. Because we did open source our protocol, but we are also focusing on building our own product. That means if there's a DeFi project want to use our layer 2 solutions, they might be our competitors. That's a concern. I mean, like not like Alex, zkSync, and Kelvin's optimistic rollup solutions. They only focus on building the infrastructures, helping the product team onboarding the layer 2 solutions. But for us, we're also building up our own product. We have our own decentralized exchange and also our payment. It's a little bit difficult, but as I say, we have already open sourced our protocol. By far, there are two projects have been using our API and design document to build up their own transfer product with our API. So my takeaway will be to make sure that your API is written in a very neat and clean way, so people can read it and understand straight away. For the others, to be honest, I don't really have much takeaways because from my point of view, I think it is not easy to understand zk rollup to a ordinary developers. They have to communicate with teams. I don't know. I would like to pass this question to Alex. Like how much support do you offer to the community, or like we know Curves just announced they're going to use a zkSync to scale up the solutions. So I would like to ask, like, if I'm a wallet project, I want to choose your network, what kind of support do I get?
Sure. So we're absolutely happy to assist projects in migrating to zk rollups. And I agree, it's pretty hard. It has been very hard for people to understand how to program zero-knowledge circuits, because they're very specific. They require some mathematical knowledge. They require special ways of thinking about that. That's why our goal have been from the beginning to make tools which make it very simple for normal developers to write this code without mathematical background. This is what Zinc is. You can write Zinc code the way you write Solidity, the way you write Rust. Like if you can read the code, you will immediately see and understand what it does, and it will actually do what you see. No hidden things where you forgot to do some special constraint and this and that. But we want to go in further, and we're working on making Solidity contracts also compilable into Zinc. And this, and we know that other projects are also working on this in zk rollups, and this will be possible sooner than even we thought earlier this year, because there's been really big progress in zero-knowledge space over this year with recursion and with optimizations and provers and other things. And it allows us to put things in Essentially, like there are no constructs in Solidity which cannot be mapped in Zinc now. And this makes it possible for us to make this transparent. So at the end, for the projects, it will be as simple as the goal which Kelvin pointed out, to just take your existing code and deploy it on the zk rollup. That's it.
I also got a question, says if the curves building up their own circuit and also have their own ray layer, and says maker or compound, they want also use your solutions. Do they have to build their own ray layers? And if those two ray layers can be bridged, or they cannot be bridged?
No, we see it all. You generally cannot have composability atomically between different layer 2 solutions or between layer 2 and layer 1. So in order to have composability, projects have to live inside the same rollup. So you would have to deploy them in the same zkSync environment, and then they become composable just exactly the same way they are in Ethereum. So any contract can just call functions of any other contract, and you can have them atomically in a single transaction. I still think that we will have multiple layer 2 solutions, and we will need some interoperability between them. But this interoperability will be synchronous. So you will be able to pass messages and pass value from one rollup to a different rollup. Depending on the nature of the rollup, it will be faster, slower. So like it will be really easy to move assets between different zk rollups. It will be a bit more difficult to move funds to optimistic rollup and back, because with optimistic rollup, you have this longer delay periods for exits. So you need some additional liquidity providers who will have funds in the opposite rollup where you want to move funds into. So we will see how that works. But I think eventually we will have a few big ecosystems, a few big rollups where we have a lot of projects in those rollups and some interoperability between these ecosystems. And I think that the ecosystems will have to be offering some unique features for the users to attract them. So I think there has to be something interesting that you cannot do in the other ecosystem, that some projects will prefer this one over that one. So I'm really, really excited to see what these things will be. So for us, we're just going for like maximum genericity and compatibility with existing Ethereum contracts and maximum security, so that you can actually put $1 billion there and be sure that it's fine. So I'm curious what you guys think about this idea that how do you see the competition between different ecosystems? What would make people move to one or another? What unique advantages you see in your solutions over alternatives and so on? So that's a question to everyone.
Yeah, I mean, I that was sort of like part of my primary agenda to talk about here. I totally agree with you, Alex, that I think, like, you know, when I look at the layer 2 landscape now, and I get this question a lot about like how we fit in there. I feel like it's very complementary right now because of the trade-offs that each of the projects makes. And I think, like, in the conversations that we've been having with partners, there's like, I mean, I talked to a wallet last week that was like, we're kind of setting up a UX nightmare for integrators and users. And like it's this like sort of feeling of impending doom. And the other thing that's happening as we talk to people are sort of like in kind of a wait and see mode to see what happens. And I think that hurts all of us. You know, people are sort of waiting on the sidelines. So like, I think interoperability is something that we'd love to talk to the other layer 2 projects about. And I think, like, I mean, there are sort of two avenues here. There's like, we've been sort of thinking about integrations, making integrations easier, you know, so like maybe standardizing in some way, having some kind of general common API that we might be able to build to, and then if an integration happens, it sort of opens the door for another one. But I think the big one is something you touched on, which is liquidity. And I'm not really sure, like we have some ideas, but I know that's going to be pretty difficult to do. But I'd love to talk to, I mean, we'd love to talk to all the projects here and other L2s about how we might be able to achieve that, because I think it's generally good for the entire space.
Yeah, for sure. So standardization, I agree, is a super interesting topic to go into. And maybe a bit of a challenge to get everyone to agree on the same standard as well. So interesting discussion for sure. So I'm just going to ask, maybe in general, again, feel free to jump in. I really appreciated the questions from Alex and Jay. That was really fun. Maybe one a bit more to Kelvin. So I was discussing with someone the other week about front running bots and dexes. So the kind of question is, do issues arrive with front running bots on dexes, and how can such challenges be mitigated using layer 2 solutions?
Yeah, I mean, front running will be an issue always, when as long as we have the time dimension, front running will be an issue. I think this problem is sort of, yeah, this problem can be, always can be mitigated in certain ways, and the fancier you get with your math, the more you can mitigate this problem. But in general, this is always going to be a thing, right? And in general, this idea of, yeah, well, unless everything is sort of cryptographically hidden, and you can somehow make sure, there's a lot of asterisks there, but at least as it currently stands, front running will exist on these systems. And so the question is mainly, how can we make the best of that, right? And so today, like, front running is sort of, people just, they do these gas auctions, and then they put their transactions up early in the block. But the assumption is that will eventually extend to the miners, because they have control over the ordering of the blocks. Will just front run everything themselves, which makes total sense. So kind of our strategy on this has been, instead of trying to just solve this issue straight up, at least for now, the response is, well, maybe we can just capture some of this value, right? So this is sort of the MIVA vision of optimism, whereby we say that we give a party by auction the right to basically control the ordering of transactions for some period of time, and then we capture some percentage of that value and redirect it to public goods. So if we can't at the moment figure out a great way to just flat out prevent front running, might as well accept the fact that it's going to happen and take some of that money and use it for interesting, useful things, at least until one day we figure out the perfect anti-front running solution. So I'm very curious to see what people think about this, but I genuinely think it's an extremely smart construction to just capture this value and redirect it. And I mean, then we can run crazy experiments and pump a bunch of money into people doing weird governance things and all that stuff that right now is sort of, there's like Gitcoin doing it, right? But who else is doing this?
Yeah, for sure. Definitely an interesting way of thinking about it. We actually use Gitcoin for some bounties at the moment. So it's a very good platform, I feel. So I'm going to have another question to Kuba. So in terms of expected outcomes for the user and having access to layer 2 payments, what are some of the pros and potential cons that they might encounter in their user experience compared to using layer 1 Ethereum for payments in dApps and Golem?
Yeah, like I'm kind of on the optimistic side. Like, I don't believe in UX hell. I think we'll manage this. And this is because, you know, people will, and people's tokens and smart contracts, they will live on layer 2 and never touch layer 1. And this is for sure. And it will be cool, it will be fast, it will be cheap, it will be secure. Yeah, I'm optimistic, but you know, to get there, we have to get all the wallets and Zerions and Zappers and Dexes and all the other tools out there. And of course, that's a challenge. And yeah, but actually, I have a question, because there's one thing that Golem as a project that needs layer 2 really needs, and I haven't heard about like anyone working on this. So imagine we want to onboard a developer which is like not crypto native and crypto friendly. The obvious solution is to use some kind of cool solution like Ramp Network or Wire, you know, this one-stop widget solutions that you embed into your application, or like our Golem setup command. And it allows them, like without any KYC, to enter a credit card, and you know, they're on-ramping straight to layer 1. But what we really need is on-ramping straight to layer 2. And this is an issue, because we will get prices like $10 per ERC20 token transfer again soon. And this is like completely cost prohibitive. And I wonder if any of you are like cooperating or heard about a project that is kind of working on a straight to layer 2 onboarding solution like this.
Well, I mean, I think everybody is going to work on this, and we will see integrations from this payment solutions once we can show larger traction and there is demand from users. So, we are talking to providers, we're talking to exchanges, so we will, this is definitely gonna come, because you simply cannot sustain the growth of ordinary users on layer 1 itself. So we're talking to wallets which are aiming at mass adoption, and they face the same problem. They will need it for their users to be able to go directly on layer 2, because you cannot create 1 million accounts on layer 1 for now. It will be just absolutely unsustainable.
Do you think like alternative bridges can be created? Like, of course, like one way to onboard user to zkSync is like to use deposit function, and user can deposit their funds. But the other way would be to some party to kind of deposit a lot of tokens to layer 2, and then build kind of a bridge, and you know, receiving tokens on the layer 1 side and sending them to the same address on the layer 2 side.
Yeah, that's exactly how it's going to work. So you will have batches. Like if you think of an exchange who needs to pay out people in layer 2 directly, what exchanges do now, they wait for a batch of transactions and they do a single batch on layer 1. In the case of layer 2, they will wait for the same number of transactions and then make one deposit transaction into layer 2 and then pay it out in multiple, or in a batch. So it's really easy to integrate for now.
Yeah, one of the things that we've been talking to some of our potential partners and integrators with is this idea of possibly like minting on layer 2 and then exiting on layer 1 later. So that's something that for us would look like a transaction type. You create it and then you basically exit and you mint on exit or something like that. And so that would be sort of like direct to layer 2. And if it's possible that you would never have to leave, you know.
I think that would be kind of the ideal world, is just staying on layer 2 indefinitely and being able to connect to the different solutions.
But which one?
Yeah, well, if we can connect them all, we can be on all of them at the same time.
Yeah, I didn't necessarily. I mean, in terms of the UX issue, I wasn't necessarily trying to be like a gloom and doom, but it like talking through some of those issues out of the gate has been like, oh yeah, like we don't necessarily like, we come from the infrastructure side, and then speaking to some of these customers and getting the perspective of wallet, it's like, like they want to hide all this UX stuff from the users, which makes plenty of sense, right? Like users just really want an application, and so it comes down to like what I think of as like transaction types to them, and then how do we insulate all that stuff, and then it comes down to like, yeah, how do we prevent some of the liquidity islands that we possibly could form?
As an open-ended question, at least right now, how reasonable does it seem to construct standards now versus later or something like that? Are there enough patterns right now that we can pull out of all these constructions that we can start to make these standards? Or is it the sort of thing where, it's going to take another X amount of time to discover these patterns?
So well, one approach is to grab an XKCD comic, which is like, what I'm talking about.
The classic one, of course.
So, wait, which one is that?
The standards comic.
The one where the great thing about standards.
Like, well, I'll just show my screen. But yeah, well, I can easily find it. Anyway, like it's about like everybody coming with their own standards, and then you have N+1 standards at the end.
Yeah, exactly.
That's a really interesting question. So, I think it would be easier to have standards for interfaces to external things, like standards between rollups and wallets, for example. Mm-hmm. This is something that you connect like one set of projects to a different set of projects, which is like electric appliances and electric grid, and you need the standards because otherwise they simply cannot talk to each other. And I think this is long overdue, not just for layer 2, but for layer 1 projects. So like whenever I have to sign a transaction on my Ledger wallet and see a hash, and this hash is truncated, and I'm like, I hope this is the right one. And then even if you see something of it in the MetaMask, it's always truncated. And if it's some specific transaction call, you might not see exactly what's going on there. Or if you sign noisy safe transaction, you also don't know, like, was the depth side of noisy safe hacked or not? Like, is it the correct one or not? And you have to go and verify it through, like, on your wallet. So I think we definitely need more standardization for such things in general. And I think it's a role of Ethereum Foundation and other organizations like this to coordinate this activity, but it certainly can also come from projects.
Yeah, I think it might be possible to do something that's not, if it doesn't necessarily have to cover the entire, the entire integration, right? Like if it's something like just for a certain application, like for wallets, maybe we can build, like each project might be able to build like a library or plugin towards that standard for a certain application, and covers like, the happy path or 90% use case, something like that. But yeah, I think it's also like, it does feel pretty early, but I would be great for us to have a conversation to see if we could at least find some common patterns. I think at a high level, things sort of like to me, it looks like things have sort of settled into, like, architecturally, things that look generally the same for a layer 2. If you squint and you look from far away. So maybe there's some opportunity there, but I know the rollups are, you guys are still building, so there's probably still a lot of movement. I mean, we're still in research too, so.
Besides the wallet layer, sorry.
What's that?
Besides the wallet layer, what are the other sort of areas that you think are worth standardizing around in the long term, at least?
Obviously, inter L2 like transfers or transactions.
Yeah. And as hard as the integration stuff is, I feel like that one's harder.
Yeah, for sure. It's a bit of a tough topic, but very interesting to dive into. So we also wanted to leave some time open for some Q&A with our audience at the end of this session. So maybe have about 10 minutes just to have some questions in the chat box from anyone that's joining us. I read one.
I have already some questions,
Yep.
but first of all, I wanted to share a comment from a participant that says that it's Kasima's birthday. So happy birthday.
Oh, happy birthday.
And
it's not every day is my birthday at OMG Network.
was a meme. Was it a meme?
Become a thing. It's always my birthday here. So yeah, thank you for remembering that it's my birthday.
Again.
I don't think anyone knows what my actual birthday is anymore at this point, but yeah.
That's cool. That's a cool joke. Good joke.
If you could see our internal troll box right now, it's exploding right now with all these happy birthday Kasimas.
We may implement that at Golem too. Great.
Yeah. I've tried really hard to make it someone else's birthday, but it doesn't work. It's just always my birthday.
Cool. So let's share the first question. Karim is asking, please ask the other panelists how they see and look to the front running issue. So I think that was your question, Jay, if I'm not mistaken. So
actually,
maybe I forgot it.
What was Kelvin?
Okay.
No, Kelvin answers.
Yeah.
Sorry, you're not the
I'm happy to answer.
Yeah, go for it, Alex.
So we definitely see it as a big problem, and I don't believe that this is a problem which is always going to be with us, because we have this beautiful technology called zero knowledge proofs, and it's like a silver bullet for everything. And you just apply zero knowledge to front running, and you solve front running. And the way you do this is, and this is what we actually plan for zkSync. You can encrypt transactions and submit them to the network in encrypted form, and make the validators agree on the block contents, what actually goes in the block, before they know what's inside this transaction. And then you use a VDF to decode the secret to all the transactions in the block. And then after the block is finalized, and this is verifiably known period of time, you decrypt them and you execute these transactions that you already committed. Say should the validators disagree, like try to exclude the transaction, they would have to be slashed and pay large fees. And you can only do this if you have zero knowledge proofs, because you need to on the user side, you need to efficiently prove that what's inside this block or what's inside this envelope is actually a valid transaction, and I have enough funds to pay. And you need hardware VDF to be able to decode these encrypted keys. And you also, like, there are some technical nuances. You have to prove that you actually correctly encrypted this transaction, that after VDF is unlocked, you can decrypt it. But this will essentially solve the problem. So this is one way. Like, there are also multiple alternative approaches. This would introduce some small delay into opening of the blocks. So your transactions will still be instantly confirmed, and you will know that they're included, but you will not know at which position. And obviously, if you interact with the DEX, you will not know exact price until everything is opened. But even right now, we have this small delay in Ethereum of 15 seconds for blocks. So if it's like 15 seconds, 30 seconds, it doesn't really matter. The benefits you get are overwhelming, because with front running is a lot worse than, say, arbitrage. Arbitrage is like everyone knows that the prices are in disbalance, so everyone rushes to try to balance them out. But front running is pure robbery. Like, you go with your large amount of funds and you want to dump it and exchange, say, DAI for ETH or something. And then everyone sees that, oh, this guy just brought this amount of money, and like any possible margin which can be gained from you will be extracted. Like, you will lose most of the value which can be lost. All right, so this is absolutely unfair, and yeah, I don't think we can tolerate this and say like, oh, this guy's could do something good with that money, because like you just want to prevent evil if you can prevent it. I think we can.
I just want to add on, because Loopring is also using zkRollUp. We pretty much have the same solution as Alex describes. So it's also a strength for using zkRollUp. So we don't really have these issues.
Right. So if no one has any other answer, we can pass to Trivia's question, which asks about composability across L2. Who wants to start?
Well, I started already. I said earlier that between layer 2s, composability will be difficult. It's very similar to composability between different shards. So different L2s are, in essence, different shards. They just like coming earlier than any sharding implementation itself. So it will be much cooler to see, for me personally, shards in Ethereum more akin to shards in, say, near protocol, where you can just use data space, bandwidth of data from multiple shards to commit the data. But if your applications have to live on different shards, the communication is always asynchronous. Like you cannot make a call and get a return in the same transaction, or say like span multiple contracts on different shards in the same transaction. And if it's asynchronous, you can still have composability, but it's going to be a very different kind of composability than what we're used to on Ethereum. Yeah, so I don't really see it possible between different layer 2 solutions. It's definitely possible.
No flash loans, sorry, no flash loans.
No, what, sorry?
I'm just joking, no flash loans between layer 2s, right?
Yeah, I mean, I think generically this just looks like message passing, you know, pass blobs of data to other chains, and then you don't really, you don't know when it's going to be received. You don't know if it's going to be received at all, and you kind of have to construct your application around that. So it's a different mental model. It doesn't quite look like how applications interact on layer 1. Right? We can still, I definitely think it's still possible to build applications that do this, but it fundamentally requires a shift in how people think about interacting with smart contracts.
Interesting. Okay, we have another question, and this has to be the last one, I think, because we're running short on time. Oh, okay, there's another one. Okay, let's do 2 then. So do you see DeFi and other composability dependent contracts being implemented on various layer 2 as a potential UX nightmare?
So, well, for composability within a single layer 2, it's going to be a much more delightful UX, because you're going to get this quick confirmations. You're going to have much lower prices, so you can have a lot more done. So for example, aggregators between different DEXs are going to be much more efficient, and so on, and like things like this. And yeah, so you will just pick the ecosystem where you want to conduct this transaction, and you will do it there. And if you need to move between different ecosystems, well, it's like moving funds between different exchanges right now, right? You will just have to do it. So hopefully we will have this fast tracks, highways to move a lot of transactions cheaply between them.
Great. So finally, the last question. I always wondered why we need so many L2 solutions instead of one. Is there such a need in space, or finally, will we all evolve into one? Thoughts?
I think in the short term, the real answer is that we don't know where people are going to go. We don't know what people's preferences really are, and we kind of each have our own ideas of what those preferences look like, and we're all building the thing that we think people will want the most. In the long term, I would say there's probably going to be a few large systems. It's probably going to follow an exponential curve where a lot of people are on a few, and then maybe there's a lot of smaller ones. I don't know. Does that?
Yeah, I think I generally agree with Kelvin on that one. It's like we're all making our bets here on where we think the space is going to go, and it doesn't necessarily, like I said, I don't think necessarily it's like consuming. It's not a zero-sum game here. I think we're all sort of aiming at different parts of the market, and it's like very, very possible that all of them would do well. But if we crowd into just one, then we sort of recreate the problems again.
I also agree with Kelvin that we're probably going to see something like power law distribution of the Pareto principle for these different solutions. We'll see a few ones which are big, and I think that these few ones which get a lot of traction, and this is inevitable because of composability, because we'll need composability inside them. They will have to expose very different characteristics. They will have to make different trade-offs that will make people prefer them for different things. So for example, rollups are like zk rollup is going to be the most secure solution. This is like beyond doubt. This is by far the most secure solution for a lot of funds put in a single thing, like billions of dollars. But we will never be able to offer transaction prices which are absolutely negligible, because the data has to be put on chain. So the transaction prices in zk rollups will be roughly 100th, maybe less, of the cost on layer 1. So if you need something like super small microtransactions, and you actually not care that much about like security, maybe it's some token transfers and games, but you have millions of those transactions per day, maybe you're better off using Plasma. You don't need to pay for this absolute security of zk rollup. So like this kind of things, this is what I'm really, really curious to see, like what these trade-offs will look like. But within a single class with similar characteristics, I would expect that you have one or maximum two solutions which will absorb the most use cases for that class of solution.
Yeah, I just want to say I agree with you guys all. But I also want to say, think about back in 2018, when there are many public blockchains just pop up, and now see how many of them just goes away or goes off. So same, layer 2 is still in a very early stage. We can't tell at the moment, but maybe next year we will see more solid cases coming soon.
Well, layer 2 looks a little bit more legit than a lot of the Ethereum killers of 2017, Jay. Let's hope that. Yeah. All right, guys. So we're finally on time. Thank you so much, everyone, for joining us. Thank you. I saw so many familiar names as well on the attendance. It's just like real life, right? No. Okay, I look forward to the day that I can see you all on real life and host everyone as well. And yeah, thank you so much. We'll post the event on YouTube and we'll share the links for everyone. And have a great afternoon and evening. Bye-bye.
Thank you so much,
guys.
everyone.
Thanks.
See you guys. Bye.
Bye.